All right, so you can use matrices to solve systems of linear equations, and for a system of maybe two or three equations, that's not that useful. You might as well just graph it or use a substitution method, or any of the methods you've learned already. But if you have a system of like 20 linear equations and you solve that, matrices are awesome. Um, well, they're awesome even with the simple systems because they're just very fun. It's kind of they take a lot longer to solve a lot of times, but it's fun. Um, anyway, before you solve a system of linear equations with a matrix, then you first have to represent that system with a matrix. So, here's a system of linear equations. Two, although I should say, um, I should, kind of bracket these to say this is a, that's kind of a sloppy, but I should say this is a system, this is a system, like these equations go together. Um, um, what was I saying? Okay, so this is a system of linear equations, but to solve that with a matrix, you have to figure out how to translate what this is saying in the form of equation into the rows and columns of a matrix. A matrix is just rows and columns of numbers. So how do you turn this into something that looks like a matrix? So that's what this lesson's about. And I just yeah okay just gotta make it look nice. So let's start over here. Um, I've got two linear equations in standard form. So I've got the variables over on one side, and then constants over on another side. And what I can do is I can represent this part of what's going on with a matrix where I just basically put the coefficients of the variables um, into a matrix. So, and it's important that I'm putting x and y in the same order. X on the left and y on the right. Uh, left, right. You know. Okay, so I just take these coefficients, these numbers in front of the variables, and put them into a matrix. So, 2, 3, -5, 4. And then I can make a matrix of the constant part. 12, 20, right? Well, I can take these and then write what's called an augmented matrix. Augmentation is where you add something to something else. Well, I can write an augmented matrix, which is basically just putting these two matrices together um, here. So, and let me rewrite this in a better form, or something. I mean, in the books, it would probably look more like this with the solid. So we've got the coefficient matrix here, the coefficients of the variables up here, and then the um, constant matrix or the solution. I forget what you call it. Anyway, the side. So you separate it with a bar to remind yourself that you know there's two different pieces here. So that's an augmented matrix. A augmented by B is equal to is this. Okay? So this is I've taken this system of linear equations, written as equations, and I've rewritten them in the form of a matrix. So these things mean the same thing. They just look different, and you can do different cool things with them. So this is, like I said, an important skill for when you're solving systems of linear equations using matrices rather than, graphing or whatever your other favorite method is. It's important to be able to first kind of translate your system into something that a matrix can understand. So key thing is to get just constants on one side, just numbers, no variables, and then variables on one side, and make sure your corresponding variables are lined up. X's, Y's, whatever that happens to be. So that's the first step, and then just write it as the augmented matrix. So let me give you some examples. Uh, Here I've got an equation in slope-intercept form. Here I've got the equation in standard forms. That's fine. I want that. So I need to rearrange this guy a little bit um, first. So I'll just actually let me just here. All right, so top guy's fine. Let's rearrange bottom dude. Um, I guess I'll just subtract 3x from both sides to move it over. So I've got y minus 3x. What's left over equals 8. And I want the x's to line up, so I'm just going to rearrange this to minus 3x plus y. And I'm going to call that 1y, just to make it more obvious. Okay, so I've got negative 3x plus 1y equals 8, and then this original guy, 2x plus negative 4y equals 8. Okay, now let me write this as the augmented matrix. Let me do a different color. This orange is kind of bothering me. So first I'll do the, so I've got my bar here. That's going to kind of symbolize this equal sign. Oh yeah, these are the only two. This is, yeah, okay. So let me work on my coefficient matrix first. So I've got negative 3, 1, 2, negative 4, and then for the constants I got 8 and 8. So now I've represented this system with a matrix. And now I can do like cool matrix type stuff with this to get the solution. Let's do this one. These top two are okay. No, the top one is alright. We've got to do some rearranging. So first of all, so we've got x, y, z, and then a constant. So that looks fine. We want x, y, and let's get the z over there too. So we could rewrite this as 2x plus 5y minus 4z equals, to move that over there, equals negative 5. Okay, so here's our first equation, second equation. Okay, now let's see. This is kind of a mess. Alright, I'm going to subtract 78x from both sides. So let's write that as negative 78x minus 7y. I'm kind of rearranging it as I go. Plus 8z. And then this this plus 10, let me move it over to the other side. So I'll subtract both sides by 10. So then I've got negative 10. So that's the third equation. All right. So we've rearranged that. So now I can represent this. It's gonna be a little hard to see. Sorry. So we've got our x's lined up, we've got our y's lined up, our z's lined up. So we just write in the coefficients. So x coefficients 4, 2, and negative 78. Then what do we have? 3, 5, and negative 7. 3 for the y's. And then 2, negative 4, and 8. Sorry, it's a little messy. 24. What is this? Oh, that's negative 5. Yeah, sorry. Yeah, important to do math neatly so you can see what you're doing. Especially with the matrices, you'll be doing all kinds of crazy stuff. 24, negative 5, and then negative 10. So so that would be the augmented matrix. That would be a way of expressing what's going on here with this system of linear equations. So then you could go on to do cool stuff with this, and then actually get a solution just by playing around with the matrix. So all right, so step 1, rearrange if necessary the equation so that the x's and y's, or whatever the variables are, so they line up with each other, and so that all the variables are on one side and all the just constants are on the other side. And then write the coefficients in their proper places in the augmented matrix.